Welcome to the video lecture on the course of AMP and linear integrated circuit. In this session, we will be discussing about the three-terminal adjustable output regulator or adjustable voltage regulator. In the previous video sessions, we have seen how a fixed voltage regulator was converted into adjustable voltage regulator by inserting a potential divider on the output side and varying the resistance R to the adjustable output could be obtained. Now here we are dealing with the IC, that is the three-terminal adjustable regulator. So the output voltage can be adjusted from 1.2 volt to as 57 volt with the help of such regulators. So the variation is from a minimum value to a maximum value, that is 1.2 volt to as a 57 volts. In such regulator ICs, the common terminal plays the role of control input, hence the called adjustment terminal. We denote it as ADJ, adjustment terminal. So in normal ICs, the fixed regulator ICs, input terminal, output terminal and a common terminal, whereas in adjustable regulator ICs we have input terminal, output terminal and the adjustment terminal. We denote it as ADJ terminal. The LM317 series is the most commonly used three-terminal adjustable regulators, and the power rating of such regulator is 1.5 ampere. The maximum input voltage of LM371 is 40 volts. So the maximum input voltage is this. So we have to provide a maximum input voltage. If voltage above this is provided, then the IC may not give its proper operation. The connection diagram of a LM317. So this is the block diagram or connection diagram, what we can say. In this case we are using two resistors, R1 and R2. The common terminal is represented as the adjustment terminal ADJ. The LM317 requires only two external resistances R1 and R2 to set the required output voltage. As we have seen in the adjustable output voltage regulator, a potential divider of R1 and R2 was inserted on the output side. The same is used in the IC part itself. Now seeing the pin diagram here, the pin number 1 is the adjust terminal pin, pin number 3 is the input pin and pin number 2 is the output pin. Internally it develops a reference voltage of 1.25 volt. So this particular IC LM317, it develops a reference voltage of 1.25 between the output voltage, output terminal and the adjustment terminal, which is denoted as V reference. And this voltage is impressed across the resistance R1. For constant V reference and R1, the current IR1 is also constant. The resistance R1 which sets the current IR1 is called the current set resistor or the program resistor, what we call. So it mainly depends upon the resistance R1 what we are going to set at this particular part, that is the program resistor. By applying KVL to this particular circuit connection diagram, we can write here V0. The output voltage is nothing but drop across the resistance R1 and drop across the resistance R2, VR1 plus VR2. Therefore, we can write here V0 will be equal to IR1 into R1, that is drop across the resistance R1, plus the current flowing through R2 is nothing but IR1 plus adjustment current IADG, that is I adjustment. So IR1 plus I adjustment into R2. Now, as we have seen previously, IR1 is nothing but V reference divided by R1, which is 1.25 divided by the resistance R1. Substituting in the above expression and simplifying the output voltage V0, we get V0 will be equal to 1.25 times R1 plus R2 divided by R1 plus I adjustment into R2. The current I adjustment is very small, and hence the drop I adjustment into R2 is also very small compared to the other term in the output voltage, and we are going to neglect that particular term of I adjustment into R2. Therefore we get the output voltage as V0 is equal to 1.25 times 1 plus R2 by R1. The output voltage is a function of R1 and R2, keeping R1 fixed and varying R2. the output voltage can be adjusted. So by varying the resistance R2, the output voltage V0 can be adjusted. So this is how we get a adjustable output voltage using the IC LM317. And again, LM317 is a positive voltage regulator. The output voltages are in terms of the positive values. Suppose if negative values have to be used, then we have to use a IC LM337 one, which gives the negative output voltages. So with this part, we obtain a adjustable output using 317, adjustable positive output we can say using 317. So thank you for watching this video.